My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 614. In this lecture, we will try to understand convolution layers in Keras. So, this is LENET architecture that we have seen earlier. In this lecture, let's understand some basics in Keras on how to implement a convolutional layer. So, for convolutional layer, they have both convolution and max pooling. We will see some simple code examples to understand how Keras facilitates writing convolution layer and max pooling layer very easily. We will take LENET as an example. Having said that, let's look at the code. I will provide the reference in the description section of this lecture. I will provide the links to all these documentation. This is not, I can say this is not exactly LENET 5 architecture that we have seen it. It is not exact architecture. There are some differences between this and the LENET 5 architecture. This point is important. There are some differences between this and LENET 5 architecture. We can say that this code is inspired by LENET 5, but it serves our purpose because all we are trying to learn is how to build convolutional layer. So in this whole code, again we will see that the model is, what is this model? Model is model equal to sequential, isn't it? The model is sequential. So this code snippet is trying to build a model first. That is important. So there are 3 steps here. What are those 3 steps? First, build a model, then you compile a model, and then you run a model. So these are the 3 steps that are there in Keras. Building model is defining. What is the meaning of building model? Building a model is defining the architecture, isn't it? You are defining the architecture, and in compiling the model, what is compiling the model? You are giving metadata or some information like what is the optimizer that you want, isn't it? Compiling model means what is the optimizer that you want to run. Things like that. When you run, you are actually run the whole model on your GPU or CPU, isn't it? I will show you how to build convolutional layer. Okay, the most important pieces of the code here is so you are building a sequential model, isn't it? Because it is why it is sequential model? Because it's one layer after the other layer, isn't it? So look at this. You are saying model dot add conv2d, isn't it? This is a function. This is a function which helps you to add convolutional layer on top of it, isn't it? That is model dot add convolution 2d. You can mention that activation unit, isn't it? We can mention activation unit. That's what we are saying. Model dot add activation relu, isn't it? You can mention the activation unit after that, or there is also a way to define everything. You can combine these two into literally one line. Why? Because model dot add conv and model dot add activation, these two things you can combine literally in one line of code also. Okay, I will show you some function definitions and function references in Keras. Yes, just see this one. These two functions you can, as we are discussing, you can combine. We can combine these two lines. Which two lines we can combine? Convolution and activation. Here you have 2 functions. One function is convolution. Here actually what do we have here? You can combine convolution, model dot add model dot model dot add convolution 2D. This and model dot, there is a model dot add activation relu. Model dot add, what is this? Activation. What is this activation? This one, activation relu. This you can combine. That's what it says. This you can, if you want, you can combine these two lines into a single line. Nothing more than that, isn't it? Yes, conv2d is now we will try to understand. I will show you some function definitions and function references in Keras. Sometimes con2d or convolution 2d. They are people used to say con2d or convolution 2d, isn't it? They are one and same. There are certain differences. There are certain differences between both of them, but do not worry too much about the details of it. The second very important function that we need to understand is max pooling 2D, isn't it? And the third one is, what is third one? Third one is flatten. I will explain you each of these, and if you look at the structure, just see, if you look at the structure, it's very simple. You created a sequential model. First you created what you created? First you created convolutional layer, isn't it? First you created convolutional layer, then activation relu, isn't it? And then you are creating max pooling layer, isn't it? You created sequential model, then what you did, activation. First what you did, just observe this one. First one is what you did, you created activation, created a sequential model, then model dot add convolution 2D means created convolutional layer, that is model dot add convolution 2D. Then you are adding, then what you are adding, you are adding activation relu, and then you are creating max pooling layer, isn't it? Just I'm explaining this sequence, nothing more than that, isn't it? Just see, activation, what is this? This is activation with relu. Model dot add max pooling 2D. What is pool size equal to, comma 2, strides equal to, comma 2. These things I will explain in detail manner. Remember, in LENET actually we don't have max pooling. That is important. In the case of actually, I will go here. Just let me show in LENET what happens. Remember, in LENET actually we don't have max pooling. That is important. In LENET actually we don't have max pooling. We have average pooling, which is called subsampling here. Just see, here people used to call it as subsampling, but this code, as I told you, it is not exactly like LENET, but it is inspired by LENET. Again, similarly, after this again you are creating, just see, let me show this one, what's happening here. Yes, what you did, one more convolution layer. You created one more convolution layer, one activation which is relu, then max pooling, isn't it? Then max pooling, and so on and so forth, isn't it? The structure is very simple. Let me walk you through this first. Just what you did, observe this one carefully. Just see what you did. Just see, same thing. First one. Here, if you observe carefully, first set of convolution, this is second set of convolution. In first set of convolution, add con2d. Here in second, one more convolution layer means just you are adding model dot and add convolution 2d, isn't it? Model dot and add convolution. Model dot add activation relu. Here also I have model dot add activation relu. Here also model dot add max pooling 2d. Here also I have model dot add max pooling, then flattening, then dense. This that's what it says. What you are doing, you are one more convolutional layer, one more activation which is relu, then max pooling, and so on and so forth. Okay, that the structure is very simple, isn't it? The structure is simple and straightforward. You have convolution, activation, max pooling. You are flattening. I will explain you what is flattening is. Then you are creating dense layers, isn't it? Just you are saying model dot add dense, creating dense layer with the relu activations. remember, even in LENET, remember, anyway, this we are saying that LENET do not have max pooling, have average pooling. In the case of LENET, what is average pooling means subsampling, isn't it? Even in LENET, just say this one, model.add dense, model.add activation, creating dense layer with ReLU activation, isn't it? That's what it says. Just try to recall, just remember, even in LENET, all activations are sigmoid and not ReLU. I will repeat myself. This code is inspired by LENET, but not exactly same as LENET architecture. Even concepts like max pooling were heavily, even concepts like max pooling were not heavily used in LENET, isn't it? But they have mean pooling, isn't it? In the case of LENET, what do you have? You have mean pooling, or you can say just we have shown, just I will go back. The subsampling in the architecture of LENET, you have subsampling, isn't it? It doesn't have any don't have max pooling, have average pooling. That's what it says, isn't it? If you recall LENET, if you remember what it says, I will repeat myself. This code is inspired by LENET, but not exactly same as LENET architecture. Even concepts like max pooling were not heavily used in LENET, but they have mean pooling, which is also called as sampling. Finally, you have dense layer. Just see here, you have dense layer and you have softmax layer. This is how structure looks like. It is very simple. Defining architecture. This code is inspired by LENET 5, but not exactly same as LENET 5 architecture, isn't it? Concepts like max pooling were not heavily used in LENET, but they have mean pooling. That's what we are saying. You have dense layer, isn't it? Defining architecture in Keras is literally like writing your notes, isn't it? This is exactly right. Writing my notes. It is very simple and straightforward. But before we go and actually see more code, I wanted to explain how convolution 2D and max pooling 2D and flatten works, because these are convolution 2D, max pooling, flatten. I wanted to explain how convolution 2D, max pooling 2D and flatten works, because these are the three most used layers that we use extensively. This is just see, these are the most used layers. This is, I can say, this is con 2D. You might wonder, if con 2D is there must be con 1D, con 3D, isn't it? Con 1D and con 3D also. This is Stack Overflow. Difference between con 1D, con 2D, con 3D, where to use which convolutional neural network. This article is one of the impressive article. If someone is interested, please go through this article. I will explain con 2D. When we actually work on time series data, con 1D, I will explain con 1D when we actually work on time series data later. Con 3D is also useful. Just see, con 3D is mostly used with 3D images such as MRI images, isn't it? It is MRI data widely used for examining brains, spinal cords, internal organs, and many more, isn't it? That's why I'm saying con 3D is also useful. But in a nutshell, con 2D are convolution layer of 2 dimension. In a nutshell, I can say con 2D are convolutional of 2 dimensions are used when we are using con 2D or convolution layer of 2 dimensions are used when we are using spatial convolution over images, isn't it? For any image data you would use con 2D, isn't it? Whereas on time series data con 1D. So there is also con 3D which you can use on there is also one con 2D which you can use on time series plus image data. So we will come to it, come to that later. We will come to Con1D, Con3D when time arrives, when the context comes. Right now we will focus on Con2D because it's a spatial convolution. It's a spatial convolution on images. It is spatial because what are we doing? We are convolving the space. This is 2D space if you observe this image, isn't it? So it is called spatial convolution in images. Let's look at this first. You can define Keras.layers.con2D, isn't it? What it says, first one is filters, isn't it? What is this filters? Filters that you want, isn't it? What is it? The how many filters, or I can say how many filters that you want, isn't it? I am saying I want I want Con2D. What it says, for example, here 20 filters, model.add convolution 2D. We were saying 20. What is this? I want 20 filters, and the filter size is what it says, model.add convolution 2D 20. 20 means I want 20 filters, and 5 comma 5 means each filter size is 5 by 5. That's what I am saying here. If you see this, how many filters, isn't it? How many filters you want, isn't it? How many filters you want, or how many kernels you want. Filters and kernels are just two different words for same thing. So this is like our M. Filters means our like M in the notation that we looked at. The kernel size is k cross k. Of course, you can have different kernel sizes. If you wish to have kernels, can be k1 cross k2 also. What is my stride equal to? We are saying 1 comma 1. First one says stride on x-axis. Stride equal to, first one is stride on x-axis, second one is stride on y-axis, isn't it? We oftentimes we use same stride 1 comma 1, isn't it? If you want to have different stride on x-axis and y-axis, you can mention, isn't it? Then there is something like padding. We also padding is of two types. You have valid padding and same padding, isn't it? Padding equal to valid basically means there is no padding, isn't it? Valid equal to valid means basically there is no padding. So if you say padding equal to same, it effectively creates or does zero padding internally for you, so that your input and output are of the same size. That's what the word same means. When you say padding equals same, your input and output size are the same. Then you have bunch of other stuff here. If you want to mention the data format, if you want to data format equal to none, we are saying data format that you want can be mentioned here. You can mention the activation that you want, isn't it? Activation equal to, you are saying none. If you want to mention, you can mention the activation that you want instead of writing in two lines. See here, in one, here we are writing model.add convolution 2D and model.add activation ReLU. Instead of writing in two lines, see here, in one line you are writing convolution. Here in the syntax you are writing in one line, you are writing convolution as well as you are writing convolution and other line active. If you see here, your convolution is in different line, and in other line you have activation. Instead of doing this, instead of doing this, you can write in single line by using Keras.layers.con2D, isn't it? You have multiple kernels, right? The default is what is the use underscore bias. You can make use bias, kernel underscore initializer, glorot uniform. We already discussed this one. What is glorot uniform? For example, if you have ReLU activation, then it might make sense to have hey normal or hey uniform. We already discussed what is hey normal or hey uniform, isn't it? There are many parameters, but they are simple. Look at this very simple documentation that you have here. I request all of you to go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.